Nature has a way of letting us know that we are not the most powerful force on Earth. Hi, I'm LeVar Burton, and I'm going to take you on a journey which will expose a defiant and dangerous enemy that already lives and thrives among us. I'm not speaking about some new Hollywood blockbuster, but a real and present danger within the world we live. This natural occurrence is eating away at our structures and equipment. Some of our nation's most important systems are feeling the full brunt of the enemy's effect, including our transportation, public safety, and military systems. So, what could this enemy possibly be? It's corrosion, a silent, pervasive, and unrelenting scourge that destroys the very items we count on every day. The war being waged against this invasive enemy should not be taken lightly, as it costs our government, industry, and individual citizens billions of dollars a year. Now, you and I certainly know rust when we see it. Just look around and you may see rusty bolts or even spotted or pitted surfaces on old vehicles as they drive down the road. Now, that's the corrosion that we can see, but it's what we can't see that's even more troubling. The fact of the matter is that corrosion occurs naturally. If materials aren't treated to resist the effects of corrosion, they will deteriorate. It's really just a simple law of physical science. After we change the physical characteristics of a metal, it simply wants to return to its natural state. We may heat them, draw them out, pound on them, mix them with other materials, and manipulate metals to make them stronger or more flexible, or sometimes even both. The mystery is how these laws apply to specific corrosion scenarios and why these scenarios occur. Bill Abbott's lifelong work has been to define and monitor the effects of the atmosphere on corrosion.
Over perhaps the last decade, there's been a major effort underway within the military to understand the real field environments in which we're deploying or storing equipment.
Now that we understand the fundamentals of corrosion, let's go to the Navy's Carter Rock Laboratory located just outside Washington, D.C., and see corrosion in action.
Accessing Carter Rock Laboratory's program. Program running. Here we demonstrate the mechanisms associated with the corrosion cell. Remember, the corrosion cell must form a completed circuit through an anode, a cathode, a metallic path through which electrons flow. The Galvanic Series is useful for predicting the interaction of different metals that might be electrically connected and then exposed to a corrosive environment. The combination of materials far apart in the Galvanic Series can result in accelerated corrosion of the less noble material. This is called galvanic corrosion. In general, the galvanic connection of materials that are close to each other in the Galvanic Series results in very little acceleration in corrosion compared to the uncoupled condition. General corrosion is usually described by the depth of attack over time. It may also be described as a loss in metal thickness or as a rate of penetration, where the depth of penetration after a period of time can be estimated. This video shows the corrosion of low-carbon steel, which we find in auto bodies, bridges, and handrails. This is termed uniform corrosion because the entire surface appears to be corroding all at once.
Most metals used in engineering applications are not pure metals, but a mixture of two or more elements designed to achieve specific properties. These mixtures are known as alloys. For example, steel, our most common alloy, is a mixture of iron, carbon, and other elements. De-alloying, the next corrosion we're going to observe, is the corrosion of one or more of the component metals of an alloy.
The time span of protection depends on the metal being protected, the severity of the environment, and the characteristics of the protective coating applied. However, defects in the coating can cause exposure of the underlying metal to the atmosphere and premature corrosion. These photos show examples of different coating systems on steel and aluminum exposed in a severe coastal environment. These examples include coatings with both chromated and non-chromated inhibitor systems.
We'll take a look at stray current corrosion. This kind of corrosion can occur in almost any metal that's been buried in the soil or immersed in water. Sources of electricity throughout equipment and facilities may provide stray, alternating, or direct current, which then in turn can cause corrosion to any metal materials that's in the path of that stray current. Hydrogen embrittlement can be described as the absorption of hydrogen that promotes brittle fracture of the metal crystalline structure. The results of hydrogen embrittlement are various forms of cracking similar to that encountered in stress corrosion cracking. Cracking can be intergranular or transgranular and is more prevalent in alloys with a high yield strength. Corrosion fatigue is the result of alternating or cyclic stresses of metals in a corrosive environment. A fatigue fracture is usually transgranular across the grain of a metal. Flow-assisted corrosion, or erosion corrosion, occurs or is accelerated when there is relative movement between a metal and its environment, such as the flow of fluids through pipes.